Hello and welcome to the Laboratory Matters, where we discuss all that matters in the laboratory. I am Dr. Rani Radhakrishnan, and we move on to the concluding module in our series titled All Red Cells Are Not Discs. In the last three modules, we read about the different types of red cells, the different poikilocytes or abnormally shaped red cells. Where they're found, how do we recognize them, what is the cause of these, and so on. Now, in the last session, over the next 20 odd minutes, I'm going to try and correlate what we see on the cell counter with what we see on the peripheral smear. Now, at the end of the day, when the laboratory invests into a cell counter, we should be able to get a sufficient amount of information, either from the numerical values or from the graphs, about whether we should look at the smear, and if we do look at the smear, are we going to see anything abnormal? So, like I told you, the cell counter generates numerical values, and these are the numerical values that we give out in our report. But we should also remember that the cell counter also generates graphical representations in the form of histograms, scatterplots, and so on, depending upon which cell counter you're using. So you have a red cell histogram, you have a WBC histogram, and you have a platelet histogram. And if you're doing retic, you can have a retic histogram. You have the WBC scatterplot, you have the retic scatterplot, you have in the WBC, you have different types of scatterplots, immature cell scatterplots, platelet scatterplots, red cell scatterplots, and whatever you may. Now, based upon the information that the cell counter is getting, it generates a whole load of data. And this data will generate some flags. Flags are alarms. The flags, based upon certain data that is there, based upon some kind of formula or some kind of an algorithm that is present in the software that governs the cell counter, it will give you some flags. Look for microcytes, look for macrocytes, look for immature cells. There is an interference, you have nucleated reds, so on and so forth. All of us who have worked in the labs will be quite aware of these kind of sample flags that are generated. Now, you also know that the high-end cell counters have, apart from the FDA approved or whatever regulatory body approved parameters, there's again a whole load of research parameters. And many labs who process 500, 600, 700 samples are also looking into the research parameters to see whether that can give you some kind of an idea which will give you more information. See, at the end of the day, the more you invest in a cell counter, you should ensure that you have the sufficient expertise to be able to interpret the data that is coming from the cell counter, and also that the cell counter is able to give you the kind of data that you want. And now, obviously, with the advent of AI can be used as a very effective tool to probably tell you which sphere you look, you have to review, and if you do review, what are you going to get inside that. This does not take away the role of the pathologist, it just tells you that where you have to focus and where you have to look and what is the probable thing that you may find. It's only a guide. It is not the end all and be all of diagnosis. Now, what are the red cell parameters that we find? Again, like I told you, from one cell counter to another cell counter, things may vary. But by and large, it is the hemoglobin hematocrit, total RBC count, red cell indices like MCV, MCH, MCHC, RDW. We don't focus enough on the RDW. The RDW tells you a lot of information and it tells you about the anisocytosis of the that is seen in the sample. HTW is hemoglobin distribution, but again, some cell counters are giving it. It may have different names in different with different technologies. That tells you about the difference in the chromasia of the cell. Now, many of the cell counters give you percentage of microcytes, percentage of macrocytes, percentage of hypochromatic cells, percentage of hyperchromatic cells. Some may give you red cell fragments, some may give you flags, some may give you nucleated red cell counts. So the list is endless. These are all approved. You can report it in your smear. Report it in as part of your CBC report or part of a peripheral smear report. Now, the first thing that one sees in a cell counter report is a histogram. Now, this is a normal histogram where the RBC size is plotted against the RBC number. The normal RBC varies from about 55 or 60 to about 100 femtoliters. So everything that is between 50 and 150 or 130 is calculated as a red cell, and a histogram is generated. Now this is normocytic. Okay. Now if there is a shift of this histogram to the left, then this becomes microcytic red cells. If the same histogram shifts more towards the right, has a broader base. See, if you see here, though it starts from 50, the peak is past 100, 115 or so, and the base is very broad when compared to the normal histogram. So the histogram gives you an indication of the variation in the size of the red cell. Very little information is got about the variation in the shape. Okay, so this is more to do with the size of the RBC, because we are plotting the volume versus the total number of cells. Now, if you do plot the hemoglobin concentration versus the size of the cell, then you may be able to get an idea into the chromasia of the cell. So when it shifts to the right, it's hyperchromic, and when it shifts to the left, it becomes hypochromic. Now on the cell counter, the red cell flags will be aniso 1 plus, 2 plus, macrocytes, microcytes, hyperchromic cells, schistocytes, fragmented cells, nucleated RB cells, hemoglobin variation, size variation. So there is a lot of flags that is also generated. At the end of the day, it matters whether you're going to review these things or not. Now we are going into a little bit about the red cell scatter. Now WBC scatter is something that all of us are very familiar with. Using a fluorescent staining or a fluorescent technology, you will be able to get the different cells. If there are abnormal cells, the scatter plot moves and you'll be able to find out which cells are seen. Similarly is the red cell, where it is based on size versus hemoglobin. This will give you a more detailed picture, and it is quite the reflection of the peripheral smear. It's not available in all cell counters, and therefore one should take some pain to understand. So the normal red cells all get scattered in the center. This is like your 9 square tic-tac-toe. So this is your normocytic normochromic, or the garden variety of red cell. Now, this is the red cell volume, which moves from 60 femtoliter to 130 femtoliter, 120 femtoliter, and this is your hemoglobin concentration, moving from 28 grams per deciliter to 41 grams per deciliter. So the centers, which is what will be in a normal adult, is normocytic normochromic. Any shift of the scatter to the right makes it hyperchromic. Any shift to the left makes it hypochromic. Similarly, a shift upwards makes it macrocytic. A shift downwards makes it microcytic. So this is a very pictorial representation of what one would see on the peripheral smear. So if you are able to, what shall I say, understand and interpret this cytogram, then it makes a lot of sense. This is the RBC volume, shift to the left, shift to the right. This is the hemoglobin concentration versus the size. Can shift to the left, making it hypochromic, and shift to the right, making it hyperchromic. This is the hemoglobin content of the cell, the kind of histogram you get with it. So this is a very interesting part of technology or interesting piece of technology which gives you a lot of information. So this is your red cell scatter. Here you have macrocytes. Here you have microcyte. I'm sorry, hypochromic macrocytic, normochromic macrocytic, and this will become hyperchromic macrocytic. Normocytic, normochromic, normocytic, hypochromic, normocytic, hyperchromic. Microcytic, microcytic and normochromic, microcytic hypochromic, microcytic hyperchromic. And in this area, extreme right, when the scatter is shifted, you have hemoglobin C, sickle cells, spherocytes, and schistocytes, and acanthocytes. So the presence of shift of the scatter will tell you whether all these kind of cells will be seen on the peripheral smear or not. These are the typical erythrograms or scatter plots. This is normal. When it shifts to the left and down, it's iron deficiency. And when there is treatment, you get two scatter plots. When it's hemoglobin S plus C, you will have some sickle cells which are present, and therefore it will move to the right. A megaloblastic will be moving upwards, macrocytic hypochromic, macrocytic normochromic. Presence of cryoglobulins or immune hemolytic anemia will give you two cell populations. One will be the aggregates and one will be the slightly normocytic normochromic site. HUS will give you some schistocytes, therefore there might be a move to the right, and it will give you microcytic spherocytes. Spherocytosis shows a movement to the right. Elliptocytosis will give a broad-based scatter. Sickle cell anemia also moves to the right, and so. So when you have these erythrograms from your cell counter, you'll be able to give your diagnosis faster, and the correlation level, it is more objective than subjective. So let's take one example. Okay, this is a patient with a hemoglobin of 4.4 and an MCV which is fairly normal, and an MCHC which is slightly higher. Platelets are low. There's macrocytosis. So there's a very wide scatter. There's move to the right. There's macrocytosis, most of which is normochromic, and there's also some microcytic and some hypochromic cells. So if you look at this, there are macrocytes, there's hypochromic and there's hyperchromic. Hypochromic and microcytic, macrocytic, hypochromic, hyperchromic. So all these features are already present, and I'm able to see it from the histogram and from the scatter plot. So this is the way there's a lot of shift to the right, little bit to the bottom and little bit to the top. So you have a wide array of cells which are anisocytosis and where there is poikilocytosis. So this will be anisopoikilocytosis, probably 2 plus or 3 plus depending upon the smear. The NRBCs are also present. Okay, the NRBCs will be here. It will be seen on the WBC scatter. Now, the flags: microcytes, macrocytes, hypochromic, hyperchromic, anisocytosis, hemoglobin variation, left shift, NRBC, IG, platelet clumps. The whole garden is there. Okay, so what are my takeaways from this? There are cells of various sizes, there are cells of various shapes. There's probably, because there's hyperchromic, 22% of hyperchromic cells, there are spherocytes. There are RBC fragments which are increased over here. RBC fragment says 0.08 into 10 to the power. So the RBC fragments are increased, so I'm seeing spherocytes. I'm seeing some shift to the left, so some microcytes, spherocytes, RBC fragments, low platelets, NRBCs. Haven't we reached a diagnosis? I have. This is the smear. Spherocytes, microspherocytes, normospherocytes. You have plenty of schistocytes. Okay, schistocytes, spherocytes, no platelets, and this WBC. So it is a red cell fragmentation syndrome. So this is what I mean by saying, yes, you have to look at the peripheral smear, but if your cell counter gives you that much more information, then it is a very useful thing. So schistocytes and the red cell count, and the cell counter, it can give you a flag, it can give you absolute count, it can give you a scatter plot which shows schistocytes, and it can interfere with platelets in the impedance method. So when it counts in the impedance method and there are platelets in that, it will give you again a flag saying platelet interference. So I think it's important to look at the cell count. Now the next case, again over here, if you see the RBCs are less, hemoglobin is about 9.9 and the MCV, MCH and MCHC is slightly increased. There is the RBC volume is few microcytic cells are there, but otherwise it's predominantly normocytic, normochromic. But the hemoglobin concentration graph, there is a nice shift to the right. And similarly in the scatter plot, there's a nice shift to the right. The percentage of hyperchromic cells are 30% because MCHC is also suitably increased at 36.7. The flags show a hyperchromasia, anisocytosis, and a hemoglobin variation. There's also microcytosis. So there's microcytosis, plenty of hyperchromic cells, which are obviously the spherocytes because spherocytes are what sit over here. So again here, the diagnosis is quite obvious. So you have plenty of spherocytes and it is hereditary spherocytosis, and the larger microcytic cells or normocytic hypochromic cells can also be as a result of hemolysis. Now the next one. Here again, the RBC is very low, okay, 0.86, hemoglobin is 10 grams, hematocrit is also 10, okay, MCV is 115, MCH is 119, and MCHC is 103. Now these cannot, they're not viable, they're not right, okay. And if you look at the differential, there's hyperchromic cells and 33% are macrocytes. So you're seeing here one population which is normocytic normochromic and one population which is probably macrocytic. There's a shift of hemoglobin curve to the right. When you look at the scatter, just like you see two populations, you're seeing two populations here also. That is very significant. There's macrocytosis, which could mean reticulocytes or red cells that are larger, or red cell clumps. All can cause macrocytosis. And there is hyperchromasia, which is presence of spherocytes. There's anisocytosis and there's a variation in the hemoglobin. Now again, because of the presence of these two, which correlate so beautifully, and the huge macrocytic, we are thinking that there could possibly be two distinct cell populations. So when you look at this smear, you see plenty of red cell aggregates. These red cell aggregates are what are giving you those abnormal red cell indices, and when you incubate it probably and refeed it, the indices may settle down. So again, this is quite classic and very easily discerned from the cell count. So here, what are we getting? We're getting a red cell differential. With the WBC differential, which also gave differentials of immature cells, which gave you immature granulocytes, immature lymphocytes, immature monocytes. So when the differential became larger, then it made our task very easy of interpreting the peripheral smear. Here again, when you have the RBC differential, percentage micro, So microcytes are there, so decreased MCV. Hypochromic cells, decreased MCH. Hyperchromic red cells, spheros, sickle cells, hemoglobin C, acanthocytes, there will be an increased MCHC. Percentage of macro, there will be an increased MCV. RBCF are red cell fragments and they give you a numerical value. RBC ghosts are presence of red cell ghosts and liping. So this will give you numerical values here which will make it a proper red cell differential. With this red cell differential, with the help of a histogram that may or may not give you some information, and if you are able to find a cell counter which gives you a scatter plot, then you're really, all fine and good to go. I'd like to, just touch upon this guideline, which I think is very important for everybody who's reporting smears, that identification of poikilocytes, trying to deduce whether there are poikilocytes or not from the cell counter, reviewing the peripheral smear, and reaching a diagnosis. Very good. You've really won half the battle. But how am I going to convey it to the clinician? One, convey it to another pathologist who may want to review my smear. So the International Council for Standardization in Hematology has come up with recommendations for standardization and nomenclature and grading of the abnormalities that you find in the morphology of the of the blood that you see on the peripheral smear. So based upon the numerical value of these poikilocytes, it is graded from few 1 plus 2 plus 3 plus maybe, but the numbers are defined. Therefore, it is becoming more objective than subjective. I'd like you all to read this particular article and try and see how much of it you can follow in your day-to-day laboratory work. It's a beautiful article and the quantification is very simple, but it has become very objective and very easy to exchange slides and therefore compare reports. So to sum it up, all I want to say is that yes, the cell counter, whichever cell counter you have, is giving you some information. Little, okay, more, amazing, awesome, all that depends upon what you have. But it's important that you just don't look at the numbers because the numbers can be misleading. You can have an MCV of 88, but you can have a bimodal or a biphasic histogram which is showing two distinct populations of cells. So it's important that we look at the cell counter, we look at the histograms, look at the flags, look at the scatter plots if any, and then correlate it with the numbers that are there. The numbers are not running away. All you have to do is get your whole funders right, make a checklist, know what you're looking for, and then go and look for it. Because I believe that a picture is worth more than 1,000 words, or in this case, all the numbers in the world. So you look at the picture on the cell counter, you look at the picture on the peripheral sphere, and you cannot make a mistake because you would have compared it mentally. Your mental checklist would have compared both and you'd come up with a description and diagnosis that fits in with the nomenclature and it is easily understood by both the fellow pathologist and the clinician. I hope that this 4-part series of all red cells are not discs, where we've touched upon the various poikilocytes and ended up by comparing it with all the values that we get on a cell counter. I hope you enjoyed it as much as I did bringing it to you. And keep watching, subscribe, like, and share my website. And if you still want to know more about what's happening in the laboratory, more about how to become better and how to give your best in the laboratory, I request you to kindly visit us at thelaboratorymatters.com, where you'll find more and more videos, more courses, and more interesting information that will help you in your day-to-day laboratory work. So till we meet again with yet another interesting series of commonly seen issues, commonly seen problems in the laboratory. It's happy learning from the Laboratory Matters. Thank you. Visit us at thelaboratorymatters.com. Thank you.